Okay, for the second part of the experiment, we're working with these different type of cells. So these are pressurized cells. So we're not going to measure a change in the volume. We're going to measure a change in the pressure. So there's a pressure gauge on the top of each one. There's a pressure relief valve here. So if we're going to close that up, you notice if you look at the electrode configurations here, the electrodes, the size are the same. The spacing between these two outer electrodes is the same. The only difference is in this cell, there's an additional sort of passive electrode in the middle there, right? And we're going to look at, see how, if that has any effect on the efficiency. These are the two pressure gauges for the cells. If I want to turn those on, I just hit those buttons, 1, 2, and it'll give me a pressure reading for each one. If they come up as non-zero, what we can do is vent these to try to zero them. If they don't zero out, I think the zero button here is stuck. So if you just make a record of what the beginning value is, and then we can correct for that or subtract that off from the data. So these are cells number 1 and 2. Number 2 has the extra passive electrode in it. Okay, so here we have the setup with the two, we call them closed acrylic cells. So cell 1, cell 2. You notice here, you can check it with the caliper as well, but the spacing of these two electrodes is the same for both cells. The only difference is in cell 2, there's also this additional passive cell or electrode in the middle, so it's not connected to either side. So our first step in this setup is we're going to turn the dial the voltage down. We're going to connect up the two cells so they're vented. Each cell has a pressure gauge on the top and a vent on the top. So we're going to vent both of them. And we want to find the operating voltage, or set the current limit actually for this to run. So we want to get the current. So if I take a step back here, if I look at, I'm applying a voltage here. I have both of these cells running in series. So think of them like two series resistors. So I'm going to apply a voltage using the supply there across the whole thing, and part of it will drop across one, part of it will drop across the other. So my connection comes out of the power supply here, through this cell, goes across this jumper to the second cell, through this second cell, and then back through the ammeter, and then back to the power supply. So I have an ammeter in the circuit, so I'm going to measure the current in that. It's one big loop. I'm going to measure the current in that loop. And then I also have two voltage meters that are going to measure the voltage, so the voltage drop across this cell, and then this meter is going to record the voltage drop across this cell. On the top of these two cells, I have a pressure gauge. So if I look at them this way, I can record the pressure. So in this case, we're not going to measure the change in the volume of gas, but we'll record the change in the pressure. So if we start them at some nominal value, we seal them up tight, and then as it runs, it accumulates gas inside the cell, and that'll be recorded as a change in the pressure. So we can infer from that the change in the pressure, and then the relative amount of gas produced. So first step I want to do is find the voltage that gives me a current of 0.1 amps. So I'm going to slowly bring up my voltage. So remember with the other setup, it was about 2.2 volts that we started to see the process begin. Here, since we have two cells, we're applying a total voltage of 4.4 volts, so it's going to drop approximately 2.5 across each one, and you can sort of see that here. So these two values should add up to the total voltage here. The current should be approximately the same between those and that. So it's one. The current is the same through the whole loop, so it's the same through here, same through here. And then we'll initialize the pressure values here. So we'll either zero them out or make a note of what they are at the beginning, and then subtract that value from the total. So once I have that voltage at which we have a current of 0.1 amps, I'm going to disconnect that process. So I'll stop the process. I'm going to stop the process by disconnecting that, and then I'm going to seal up the valves here. Make sure those are closed tight. I'm going to zero out the pressures on the two, or at least make a note of whatever the value is. I'm going to start my clock, and then connect that up. And then every minute, I'm going to take a reading of V1, P1, V2, P2, and the current running through them. Right? And I'm going to put that into the Excel sheet. Once that finishes, I'm going to stop the process there. And then what I want to do is just look at my pressures on the gauges and monitor them for a minute or two, or a couple of steps, measurement steps beyond that. So if the process stops, the pressures should stop increasing. And I also want to check that they're not leaking at all. So ideally that pressure should just come up and level out, and over the, a couple minute time scale shouldn't change much. So that's just a verification that there's no leaks happening. If there was a leak at the end, it would also, you'd have to assume that it was also there throughout the process, and it would kind of throw off your measurement of the amount of gas you're accumulating. Once that's done, we can you can vent these, open them up, vent them, vent out the accumulated gases, just connect things and shut down your power supply and your ammeter, and then we're done.